Hey guys, we're looking at 2.2, lesson 2 of 2, volume of spheres and hemispheres. All right, these learning objectives are old because this is not cylinder or cone. We're doing volume of sphere and hemisphere. All right, so on slide 2, I've got a little check-in. You can drag the icon, let me know. How are you feeling today? And then if you'd like to say more, you can type in this space below. All right, slide 3. Is going to be our notes. So again, if you need a moment to drag where you're at, say about there. There we go. I'm not quite so happy that my eyes are like going crazy like that, but I'm in a good mood. So if you'd like to say more, you can type in that space there. You can pause to do that. Slide 2. All right, assuming you've edited, we're now on slide 3. We're going to be following along with some notes as a class. So we're finding the volume of a soccer ball. And I am remembering I did not include our formula here in Desmos. Double check if I put it on the next slide. Oh, I did. Haha. Here it is on slide 4. So before we dive into solving for volume of a sphere, it might be helpful if we knew what we're doing, right? What's the formula? So volume is 4/3 of pi r cubed. All right, let's just make sure. Yep, we're finding the volume of a soccer ball from the game Wii Soccer Ball. We've got some information there. So because we're finding volume of a sphere, we need to copy this formula down. So volume is 4/3 pi r cubed. So we're going to write that down. All right, so volume is 4/3 pi r cubed. I'm just going to make sure that I wrote that correctly. So 4/3 pi r cubed. Yep. Volume is 4/3 pi r cubed. Cool. So we want to find the volume of this soccer ball. I see they have highlighted the great circle. Again, the great circle is where if we took a sphere, we sliced it down the middle, right? It would split it into two hemispheres. So that line, you can kind of see it here on this ball, that line perfectly in the center of the sphere, that's called the great circle. So again, it's imagining we're slicing it almost like the equator of Earth, right? It's splitting it into two separate hemispheres. Okay, so that's the great circle there. And they're telling us the radius r is 4.5 inches. We're like, cool, thank you for that information. So we're just going to take that and we're going to plug it into our formula. So 4/3 pi, r is 4.5, and it's going to be cubed. So again, all I did was rewrite my formula, except instead of r for radius, we're actually plugging in the radius. And we do have a calculator, so we can check what that exactly is. So 4/3 pi times 4.5 to the power of 3. Whew. All right, very big number. And for your homework in Khan Academy, you are rounding to the nearest, most of the time, 10th place. Sometimes it's 100th, but we're going to do 10th for this one. So 381, and then to 10th place, 7, right? We look next door, 5 or more up the score, 4 or less, let it rest. It's 0, so nothing. We let it rest. Because this is volume, remember, our units are very, very important. Because this is volume, our units are going to be cubed. Very, very important to remember. Like, what are we doing here? What's going on? Oh, yeah, volume. Okay, volume is cubed. If it's surface area, the units are squared, but volume is cubed. All right, so this is our practice problem that we have done together. Again, also volume is like finding how much liquid it will hold, or for volume of a soccer ball, how much air will it hold, right? That's what we're thinking for volume. It's like a mass, like an amount. Like my water, my protein drink here, right? For my glass, how much protein drink can I fill up, right? That would be the volume of the glass. So volume, thinking of maybe filling up with water or air. Okay. All right, this is a recording, so we can't add this to our notes. So instead, what we're going to do is jump to our next slide for on your own. Go ahead and try this on your own. I've got the, oh my gosh, what were they called? The Wii Sports for the airplane. It was the Air Sports, because you guys were mentioning that last class. You guys were voting like, ooh, we liked that one. So I got you, Wii Sports, the Air Sports. All right. So find the volume of the sphere. I don't know where the sphere is on Air Sports. We might have to play the game and find out where this is. Maybe it's there somewhere. But anyway, we're imagining we're playing Air Sports. We come across this sphere and we need to calculate the volume of the sphere. So if we are finding the volume of the sphere, we might need the formula. So for the sphere volume, 4/3 pi r cubed. So you are doing this by yourself, but I'm going to help you out. Volume is 4/3 pi r cubed. All right, go ahead and pause this video. Try this on your own, and then in a moment, we'll go over the answer together. All right, assuming you have paused the video, you've got your answer, you're ready to check. If you have not, pause again, this is your last chance. We're gonna go over the answer now. Volume of the sphere. So for volume, straightforward, we are just plugging in the radius. And we're seeing in our figure, we see the great circle outlined, and looks like they're giving us the diameter. This is the diameter. Diameter. The diameter is right there, but we don't want the diameter, we want the radius, right? Fear not, remember the radius is just half of the diameter. They're missing a U. Radius. The radius is half of the diameter. So 14 divided by 2 is 7. So the radius, r, is 7. Once we know what the radius is, we plug it into our formula. So 4/3 pi, and instead of r, we're going to replace it with 7, and then that's cubed. So let's see in the calculator. So 4 divided by 3 pi times 7 cubed. All right, so we'll get the volume of this sphere is 1,436.8, rounding to the nearest 10th place. 0.8. This is feet, and because we're talking about volume, the units are, again, cubed. Units are cubed for volume. So if you got that also, pat on the back, nicely done. If we didn't, hopefully going through this, maybe you were able to see your mistake. Maybe you forgot to update, right? We were given the diameter, not the radius. So maybe you forgot to divide it by 2. All right, hopefully we're learning as we go, learning from our mistakes. All right, at this point in the video, I've got a brain break. So you can take a rest if you need to, pause the video, doodle in your Desmos, and we're going to continue with our fill-in notes on the next slide. All right, assuming you paused, you gave yourself a 2-minute little break. We're gonna try jumping in here too with our fill-in notes. So for this next portion, we're gonna be talking about composite figures with spheres and hemispheres. And a composite figure is just a figure that can be separated into regions. Separated into regions that are basic plane figures. So composite figure, we did look at this already with composite area, and we looked at, finding the area and perimeter given a composite shape. So we have looked at something similar with this, but now we're going to be finding volume given a composite 3-dimensional figure. All right, so we're going to go through this as a class. It's okay. We're going to go through this as a class. We'll see what's going on. All right. So I want to find the volume of this composite shape. They're kind of, I gave this visual here from the side to kind of see what's going on here. So we've got this cylinder, and then we've got this sphere cut out from the cylinder. So if you can visualize that. Maybe this is like an ice cream bucket. We scooped out ice cream. We made a perfect half circle, leaving us with this much ice cream. I don't know what else would, like, what another scenario could this be where we have this cylinder and the sphere cut out? Anyway, whatever. If you want to think of a different example, you can. But we're missing this piece. So I got a second visual to show us this, and we can update this second visual. So the height is given. The height is 3 inches. And the radius is given also that it's 2 inches. 2 inches. So because this topic is composite shapes, we should start by identifying what are the shapes that are given here. And if we were doing this not in a recording, I'd ask, what shapes do we see in this figure? And I kind of already accidentally told you, but that's okay. So we can see we're given the cylinder, and we also have this half circle. We're taking the cylinder, the total, minus this half circle to give us this new shape where it looks like this, where we're missing that half circle, that hemisphere worth, if that makes sense. Okay, stay with me. Stick with it for just a moment. So we are talking about the cylinder. Might be helpful if we have the formula. So volume of a cylinder, this is a recording, so I don't have my notes with me, so I'm going to pull it up. So volume of a cylinder is going to be pi r squared times the height. Yeah, remember base area times the height minus the hemisphere volume. I need to double check volume of a hemisphere. Well, that was already in our previous slide, like way back when. Hemisphere, here we go. 2/3 pi r cubed. 2/3 pi r cubed. 2/3 pi r cubed. 2/3 pi r cubed. Okay, so this is what we're going to use. We're going to use this information, subtract the volume of the, we're going to take the volume of the cylinder minus that hemisphere to give us this new shape. Okay, so cylinder first, we're just plugging in. So we found, so the radius was 2 and the height was 3 inches. So we're just going to plug it in. So pi times the radius, which was 2, that's why we color code, 2 squared, times the height, 3. So the cylinder volume, the total volume, is about 37.7 inches cubed for the cylinder. And now we're taking away from that total ice cream, right? We're taking away this much ice cream. So let's see, 2/3 pi times the radius, again, is still 2. And now we're cubing it to the power of 3. So minus 16.8 inches cubed. All right. So let's see what that is. So 37.7 minus that, right? Again, we're taking that, imagining now it's an ice cream tub. Like if you go to like an ice cream shop, they've got this big tub of ice cream. We took out this much ice cream. How much is left in their tub? We took out a lot of ice cream then. Wow, it's pretty crazy. So 37.7 minus 16.8, the ice cream we took out. That would leave us with actually quite a lot of ice cream left. 20.9 cubic inches of ice cream left. So that's our volume for the composite shape. So whenever we're dealing with volume of a composite shape, we need to identify some things, right? Like what is the general picture? What do we see here? I see a cylinder. Okay. And it looks like we're taking away from that cylinder this hemisphere, this half circle, half sphere, taking that away. Okay, now it's leaving us with this new shape where we had, right, the cylinder minus that hemisphere. So we're just trying to make a plan of attack when we're dealing with composite shapes. Okay, what are they giving us? What's a piece that's missing or a piece that they added to this figure? We have to calculate those and either add or subtract with composite shapes. this case, we were subtracting, but sometimes they'll add another piece to it. All right, again, this is a recording, so we can't add this to our notes. We'll do that later. All right. Oh, I guess I did have it. Wow, I had that slide here. That's funny. All right, I had to think, pair, share, but again, this is a recording, so it's a little bit challenging to do that. Try this on your own. I will put the answer key on the next page for you, so you'll see it on slide 11. And then on your last slide, go ahead and let me know, drag and drop, how confident do you feel with volumes of spheres and hemispheres? And do you have any questions for me? Since this is a recording, for the questions, I'd ask you to, instead of typing it here, go ahead and send me a Canvas inbox message. But now that we're at the end of this lesson, your quiz, you'll be taking that quiz. So I'll send you that link in Canvas inbox also. So your quiz, take that first attempt on your quiz. All right, that's it. Have a great day, guys, and I'll see you in class next time. Bye.